I'm your host G. Today, we're going to discuss derivatives. Derivatives are a wide-ranging tool throughout mathematics. In fact, some might say derivatives are global. You can't be smooth without a derivative, by definition. All the cool kids talk about derivatives, and some try to wriggle them into every nook and cranny of math. And I get it. Derivatives are really scary the first time you learn them. Without help, you may get stuck at discontinuous asymptotes. I'm here to integrate you and pull you out of that asymptote into larger and larger sets until you're better with derivatives. Who knows, with enough pulling, you may even become the next Leibniz. At this point, you've probably caught on. I'm not a sheafification of G. And with that irreducible expression off my shoulders, let's return to derivatives. While derivatives may seem complex, even convoluted at first, they're really not that bad. Derivatives are basically just a fancy way of saying that we want the growth rate of a function at one point, then another, and so on. So really, derivatives are just a way of asking for the growth rate of a function at all its points. What is growth rate? The growth rate is basically finding how much the function changes in a given interval or limit. The growth rate for the point of a function is just a given interval of change shrinking and shrinking and shrinking and shrinking and so on until we get infinitesimally close to the point. What is a limit? Well, first I would check out the real Sheafification of G's video on limits. But a limit is, simply put, an ever-increasingly accurate interval between two values, or basically gets really, really close to a given interval of a function. How do we calculate a derivative? There is the formula for a derivative, which uses a limit. I will show it on screen. There's a power rule for, polynomial functions of the form x to the m plus x to the m, so on, plus x to the a. I encourage you to play with the derivative formula and power rule. What is the derivative formula? Why does it work? The derivative formula is basically asking for how much change is occurring in an infinitesimal change in the function, hence the limit as h approaches 0. Or, basically it's asking how much does a function change if you change x by a small amount. This works because the derivative formula is basically the limit, approximating the tangent line at every point of the function. The tangent line at a point is a growth rate of the function at that point. But functions are differentiable. Only continuous functions can be differentiable. Why? Because if a function has an asymptote, then when approaching that asymptote, values either approach infinities, positive and negative, or infinitesimals, like 0. What is a smooth function? A smooth function is a function whose derivative is continuous everywhere.